Excel things so I can put the numbers in there. So hopefully it works.
Okay, let's pull the quiz, and it's it's tough because right now my classes are starting to hit formulas, and it's like, all right, which formula was for which class, and so got that going on. It's kind of annoying.
All right, I'm starting the quiz.
Okay, I'm ready when you guys are.
I'm just pulling it right now. All right, I got it up. Okay.
So funny. So standard deviation.
Okay, margin of error for 90% confidence interval where the standard deviation is 50 and N is 25. So this was z-score times the standard deviation divided by the square root of the sample size, right?
Yeah. And margin of error.
Z-score, z-score 1.645. Is that the z-score you got?
1.645. Yeah.
Okay.
Yeah.
Cool. 50, 10. 16.45? Zero? Oh, hold on.
I got 16.45. Just says round to 3 decimal places.
Adding a zero on the end there.
I guess.
Alexis, did you get 16.45?
Sorry, I don't remember the formula.
It is the critical value, so the z-score, times the standard deviation divided by the square root of the sample size.
Okay.
If that makes sense.
Oh, that's right. Okay. Yeah. Okay. 16.45. Cool.
Yeah, 16.45. Throwing a zero on for the 3 decimal places, 16.450.
Yeah.
Okay. Which of the following statements is true?
X is a point.
Estimator of that. X bar is a point estimator of the population. Estimator, no. Isn't X bar is a point estimator of population?
That's what I'm thinking.
That's what I thought too when I first read it, but I'm not 100% sure.
Yeah, I think because we want to, essentially the whole purpose of this is to find the margin of error from a point estimator. And a point estimator would be X bar. And so we're finding the margin of error based off of that point. Right?
Yeah, I think that's it.
Checking 95% confidence interval from GMAT score shows standard deviation. That 64. 526. All right.
526 is the point estimate.
The bar over X equals 526. That's the sample mean, right?
That's the sample mean, yeah, but that's our point estimate though. That's if our answer to the last question is right, then 526 would be a point estimate. Right?
What was the point estimator?
Yeah.
Yeah.
Yeah, I think so.
What is the margin error for 95% confidence level for the true GMAT score?
I got 27.685.
Remind me again this formula here. I'm gonna have to pull this one up and remind myself on this one.
So the margin of error, here, 1 second on to. The margin of error is the critical value. So that is the same. So it's the critical value. So it'd be 1.96 times the standard deviation divided by the square root of the sample size.
That's right. Okay.
So
You got 27.85?
oh yeah, I got 27.685.
1.96. 1.96 times 113.
What is the lower level?
27.685?
Yeah.
Is that what you think? Okay. Okay. What is the lower limit of this confidence level? Round it through decimals.
I got 7402.065.
So
How
this
do
is
you,
the one.
So this one is the sample mean minus the critical value times the standard deviation divided by the square root of the sample size.
So you have the sample mean, and then you
I got them written down right here. If you guys want to look at my screen and hold it up, and you guys can see the.
okay.
I don't know if you can see that, but it might be sloppy, but it's the very top.
Sample mean minus critical value.
Here, I'll just read it to you slowly. So it's the sample mean minus the critical value times the standard deviation divided by the divided by the square root of the sample size.
So you're taking, in this case, then you're taking the 526 and subtracting the
1.96.
1.96.
Then you're timesing that by the standard deviation over the square root of the sample size.
Okay.
And then divide that by the square root.
Here, let me pull it up. Then I got 7402.065.
Oh, this is right. Okay. Yeah. Okay. So it's, hold on. It's coming back to me now. Let me run through this again real fast here. Okay. So we have sample mean 526. And then we take the 1.96. We multiply that by 113 over the square root of 64.
Yep.
So what did you get here?
I got 74. So 7402.065.
So do this because remember we're talking about the bottom level standard deviation off of 526. So take your formula. Your formula is right, but the parentheses. So here, let me. What I basically computed first. The formula I used, because what I got was 498. I got 498.315.
Yeah.
So I took the 526, subtracted by, and then parentheses, the 1.96
Yeah.
times the margin of error, the 113 divided by the square root of 64. And that gives me the bottom number of 498.315.
So,
Okay, I got it when you did that.
wait. Let me tell you what I did, and maybe you'll see.
Yeah.
Put the parentheses around the sample mean and the critical size times then parentheses around standard deviation divided by sample mean size. Is that not right? I personally have the
So
All that is the mean minus, so number 6. So what we got for 6 is number 7.
let me take. So what'd you get again?
I got 498.315.
All right, that's what I got. I just had the parentheses out of order.
And then for the upper limit, we just change it to a plus instead, and then we'll get the upper limit.
Yeah. 498. You caught that. I got 553.685. 553.
553.685.
Yep.
Yep, that's what I got. Is that what you got, Alexis?
Yeah.
Okay, sweet. All right. What would happen to the width of the confidence interval if Gina increased the sample size?
Decrease, right?
It decreases it, yeah. More data equals less variance, essentially.
Mm-hmm.
What would happen? What would happen to the width of the confidence level interval to a 99% confidence level? The width would increase.
Yeah.
Yeah.
Okay.
Bright bulb light bulb company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence with a margin of error of 50 hours. What sample size do they need? Okay, so this is the one where we take the 1.96 times the standard deviation divided by the margin of error.
So,
Times 400 divided by 50, and then we take this, we square it.
Yeah.
Times the standard deviation.
246.
Margin of error.
I got 246 for this.
I have a question for you. Would
Yep.
you put parentheses around the whole thing and do the whole formula, then square root it, or do you square root it before?
For this one, essentially the way I calculate it is just I do first the 400 hours times the 0.196.
Okay.
So I get, or 1.96, sorry.
Yeah.
And then divide that by the 50.
Divide that by the.
And then square that number.
And what did you get?
I got, well, rounding it to the nearest whole number, 456. Or sorry, 256. 246. Jeez.
Okay. Good.
Dyslexia.
So,
246.
deviations
Is that what you got, 246?
That's what I got.
Okay.
Wait 1 second, I didn't get that.
Mean salary of actuaries.
What'd you get for the margin of error?
Margin of error for that last question we just did?
Yeah,
50.
50. Oh, that's what I was gonna say.
I'll probably do the next about 10 minutes probably.
Give me 1 second. Sorry, guys.
It's all good. The mean salary of actuaries is $100,000. No, mean salary.
You get 245.
245.8, and then rounding up 246.
All right, 246. That's what I got.
Okay. All right. Mean salary for this. Mean salary for women actuaries. What are not sure if it's higher or lower. The level of significance. So the hypothesis is about 100,000. We're trying to find out if it doesn't equal 100,000. 36 women's salaries are fine. 111,000. Okay. What is the lower limit of this 95% confidence interval? All right. So 100,000 is our sample mean. Our population mean. Hold on. That's our population mean.
Critical value. The
So
critical value is 0.05, right?
0.05. Well, that's our
Level of significance.
level of significance. That's what'll tell us whether or not we can reject the hypothesis or not. So we're looking for a number that's going to be less than 0.05 to reject that hypothesis. If we were going that route, which I don't think we're doing that maybe until at least the last question. So in this case, though, what is the lower limit of this 95% confidence level?
What is this formula?
This is X bar, so 111,000 minus, then the parentheses, the 1.96.
That's right.
Is that what it is?
Mm-hmm.
1.96 times the margin of error, the standard deviation over the square root of the sample size.
Standard deviation is 36,730, right? 36,730.
Yeah, 36,730. Yeah.
So did you get an answer for 12 yet?
Almost.
Okay. I just want to see if I'm doing it right.
I got a really big number. Well, not really. Actually.
No, nearest whole number. 99,002.
99.
That's what I got the first time, but I don't know why I thought it was wrong.
You got 99.
$99,002.
I got $98,002.
98. Okay, let me redo it then. So I got.
What is your sample mean? Is it 111? Oh, it's because I mapped by $1,000. That's why. I have 110 instead of 111.
Oh, okay.
Oh, so that changed it and gave us the 99.
So Alexis, what made you rethink it?
I don't know. I guess I'm just trying to think about it. Because the standard deviation is 36,000. I'm thinking it should have been less than that. I don't know. That's what I got.
Yeah, it should have been more. You're thinking?
I don't know. Maybe I'm not thinking about it right.
So let's see. Standard
If that's
deviation.
the right formula, that's what we used before, right?
Yeah, that's the one we used earlier on the same
Okay.
one too.
And that one made sense to me, so something's just off with this one. But that's the number I got.
So
I just need to read through it again.
I think one of the things with this one, so the standard deviation of the 36,730 is a base standard deviation. But remember, we're altering that number based off of the square root of the sample size.
That's
So
right. Okay.
if we just take that 36,730 and then divide it by the square root of 36, so 6, then our variance when you look at that number is $6,121.
Okay. I think you're right. That's what I was thinking about. Okay. I
Yeah.
think we're good.
Okay.
Thank you.
No worries.
Okay.
Okay. And then are we doing the upper limit? Yeah. Pretty. $122,999.
I got 998. Let me try it again.
998 too.
I got 998.4.
Yeah, so you
That would be 998.
Yeah. 122,999 because we always round up, right?
well,
To the nearest whole number.
a
4 plus
4 would
5.
round down.
Say again.
A 4 would round down.
I thought anytime we had
Um,
these, we always rounded up.
That was something it was talking about. But on the quiz it says to the nearest whole number.
Okay.
There was something in the lesson though. I don't remember what it was.
Oh, you know what it was is when we were figuring out the sample size, how many samples we need.
Yeah. Which makes sense because you can't have a fraction of a.
Yep.
Cool.
Good call. Good catch.
Cool.
All right. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are, yes, simple random, yes. Normal distributed, yes. Standard deviation. So all the above?
Yeah, that's what I
Yeah. It would have to be.
Yeah.
It can't be 3. Okay. Cool.
We good with that? We want to hit any of these anywhere? Go back through them at all, or are we good?
I think I'm good. I'll let you go to dinner.
We feel pretty good about it.
Yeah.
Well, let's figure out see what happens. How we do?
Got 100, I think.
Yeah. 100.
Yep.
Yep. Sweet. All right.
Well, thank you.
Well, hey,
Thank you guys.
thanks for coming a little bit early. Appreciate it.
Yeah.
Yeah, no problem.
All right, we'll do it again Wednesday. I think Sterling's out, by the way, now. I just stopped inviting him at this point, so we're just going to roll
Okay.
with us 3
All right. That's
Sounds
fine.
good.
until I hear otherwise, at least. All righty. Well, I'll see you guys on Wednesday then.
Alrighty, see you.
Bye.
Guys.